Go.
Hi Gr8. We're going to do experiment 1, which is on page 6 of your notes, the stuck up balloon activity. So I've got a balloon and I'm going to blow it up. Okay. So step 1, under the instructions, blow up a balloon and tie the end so that the balloon stays inflated. Blown up the balloon, and I've tied the end so that the balloon stays inflated. Without doing anything else, hold the balloon against the wall to see if it will stick. Observe what happens. So here's some wall. The balloon drops to the ground. Let's try this wall. Balloon drops to the ground. And this wall, balloon drops to the ground. So we're going to write what did happen. So the balloon does not stick to the wall is what happened. Next, we're going to briskly rub the balloon across a piece of wool. You can use a sweater, scarf, sock or rug, or if you want to do this at home with your own balloon, you can even use your hair. So I've got a jersey, that's the one that's behind in my class.
From 19-foot sack.
This is me rubbing the balloon. Remember, if you are rubbing, then that means friction. Friction means rubbing. So I'm transferring electrons between the balloon and the jersey. Rub, 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 rub. Let's see what happens when we put the balloon near the wall.
Hopefully it works. Hey, at least there is some traction there. Yes.
Let me just try and develop a little bit more.
Mr. Ginsburg is generating a charge.
The electrons are being transferred between the fabric and the balloon. It is sticking a little bit to it.
Yes. I can see that there is some sort of attraction there. It's not completely, I think it works best on the brick wall.
It's not dropping like it used to, so there is a bit of attraction. Try a little bit more.
Rub vigorously.
Let's try it on this wall. It is sticking a little bit, so it doesn't stay stuck to the wall, but it doesn't drop down like it used to.
There's some attraction there. It's not completely.
Yeah. Yeah, there is a little bit of attraction. If you want to try this at home and rub some more and try it on different surfaces, then you can do that. Try it on the brick wall. There's a little bit of attraction. Again, like I said, try it yourself, rub even more vigorously for a longer time. And then step 3 says hold the balloon against the wall to see if the balloon sticks to the wall. Does the balloon stay? In this case, not really, but the idea is that the balloon should stick to the wall. So please send us a video if you can get your balloon to stick to the wall. So think about what conclusions you can write. Think about what's happening to the atoms of the materials. Then experiment 2 on page 7, dancing balloon activity. For this activity, we need 2 balloons. You have to blow up the 2 balloons and tie each one closed so that the balloons stay inflated, and then tie a long thread. So we've got some string, tie a long thread or lightweight string, that's about 50 centimeters long between the 2 balloons. And the next step is to give each balloon an electrostatic charge by rubbing it with fur, wool or your hair, as in the stuck up balloon activity. So I'm going to try the same experiment with this balloon and see if I can get it to stick to a wall. It sticks a little bit. Let's see if I can get these two balloons to interact. So I'm not touching the green balloon, and there's no wind in the classroom, and the white balloon is causing some movement in the green balloon. So there is an electrostatic interaction happening between the two. And you could also try it with your hair as well and see if you can get your hair to stand up.
Why does the hair stand up, Mr. Ginsberg?
There's an imbalance of charge between the balloon and the hair, and opposite charges attract. So either the balloon is positive and the hair is negative, or the hair is negative and the balloon is positive, but they are differently charged. So there's electrostatic attraction between my hair and the balloon, and so my hair is attracted to the balloon. Okay, so the white balloon is causing the green balloon to move. So now the idea is that to tie a piece of string between each balloon, this is something that you're more than welcome to do at home. If you've got cotton, light thin cotton rather than string, that will work better because it's lighter. So it's easier for the balloons to move each other. You tie one end to one balloon, and the other end to the other balloon, and see if we can get the balloons to dance. It's not looking too good because they don't seem to be too charged up, but let's try rubbing some more and see what we can get to happen.
I think the hair is a better bet.
I think so too. How ridiculous do I look? So ridiculous, I think is the answer. I just want to try the balloon against the wall one more time. No, it's still not working very well. Anyway, let's try the dancing balloon activity and see what we can get to happen.
Is there movement?
These balloons are actually being attracted. In order to get them to dance, the idea is that they should be repelled. So these balloons have got the same charge.
And they're moving together almost.
All moving together. So the idea, guys, behind this is that if the balloons have got the same charge, they'd repel. So I'm going to simulate what we were hoping to happen. So if they repelled each other, they push each other apart. But because of the string tying them together, they do this and they would dance. Okay.
I think perhaps the one balloon might not have generated a sufficient charge.
Now,
Perhaps that's what
it's a
happened.
humid day today.
Yes.
If you do this in winter, that's the best time to do it.
Good.
And if you've got very, very long hair, then that's even better.
Aha,
There's a little bit there.
there's a little bit of movement there. There's a little
being
bit.
Attracted.
Wow.
Definitely being attracted to each other. So that means that they must have opposite charge. One balloon must be slightly positive, one slightly negative. Opposite charges attract according to the law of electrostatics. So that's why we get the dancing balloons. So hold each balloon by the end of the thread and try to bring the balloons close together. So if they had the same charge, then they would repel each other. So if you brought them close together, they would push each other apart. And of course, if they're tied together, then you're going to dance. Dance balloons, dance. So the balloons become electrostatically charged, they attract or repel each other, and because they're tied together, they constantly attract and repel, and that's why they appear to dance. What conclusions can we make? Like charges repel, unlike charges attract. And if you think about what's happening in atoms, balloons can be charged by friction, conduction, or induction. Thank you, Gr8.